Okay, excellent. Thank you. And hi, everybody. Good afternoon to all of you there. I'm Erick Gantt from Cadence Design Systems. I am here to kind of give you an overview real quick of our latest developments in Fidelity Pointwise, which I'll probably often just refer to as Pointwise. And just kind of let you know what's going on with our latest attempts to, automate the entire preprocessing setup, but specifically today, features that we've recently released with respect to dealing with geometry and automation of the process of preparing the geometry for meshing. So my first slide here is really just kind of the typical foundational slide to start off, everybody. I know a lot of folks that are participating here are familiar with Fidelity Pointwise, but just for those who don't, and as a reminder, here we just review the different capabilities that Fidelity Pointwise has, and it is a broad range tool set that Pointwise can provide to you in terms of geometry management, I/O flexibility. We support a lot of formats for import, native CAD files. We support a lot of flow solvers, of course, SU2 for export, and then a lot of just generic data files for grid and other needs for getting your information into Pointwise for meshing. In terms of the types of meshing you can do in Pointwise, of course, we support multi-block structured, hybrid, and fully unstructured. We do overset. We support overset meshing, as well as coupling with some of the tools that you can use for hole cutting for overset meshes. We also have high order export for a number of the flow solvers that we support for export. And then more recently, we have a number of customers and internally work that we're doing with adaptation, and we can couple Pointwise with flow solvers through what are called PCD files or point cloud data files, which are essentially just point data that have local target cell edge length information included. And then finally, Pointwise is natively scriptable. Everything you can do in the interface, and everything, in fact, that I'm going to talk about today is scriptable. All right, so as we all know, preprocessing for CFD is one of the pain points, and a lot of that pain and time comes in up front in just preparing geometry for meshing. I know the previous speaker spoke to this a little bit, and dealing with geometry and trying to accelerate that whole process. And then, of course, you follow that with the meshing. And I will say, kind of as a preface to this set of features that I'm going to talk about in recent releases, the last two versions of Pointwise, Fidelity Pointwise, we have really spent a lot of time on the meshing process itself in terms of accelerating surface meshing, and then also setting up the volume grids and volume meshing in Pointwise. And now we're kind of backing up a little bit with this next set of features to address a little bit more of this pain point, and that's dealing with the geometry itself and getting it ready for the meshing process. So there's a number of tools that we've added in this latest version of Pointwise, and the first set I'm going to talk about are kind of fall into a set of selection tools and enhancing the selection process of entities in Pointwise. And then after that, we're going to talk about some new capability that we've added for actually trimming and adjusting the geometry itself, the surfaces, or what we call quilts in Pointwise. And then we're going to really talk about the automation part at the end. So in this first piece, this is some capability that we've needed for a little while, and that's the ability to quickly and easily select pieces of geometry that are essentially identical or very nearly similar. And in the image you see at the bottom here, this is the FDA blood pump geometry. The red quilt, rendered in red, is a selection that the user has made, And using the Select Similar tool, the panel that you see on the right, you can quickly and easily select all of the other entities that have essentially, in this case, possibly the same area or perimeter. You can also set up Select Similar to use orientation based on normals of the quilts or surfaces. And you have tolerances for all of those different properties that you can specify for quickly and easily selecting similar entities. And this can really come into play in preparing geometry if, for instance, you need to do some defeaturing, removing objects that are not really necessary for your analysis, and so forth. Not mentioned on the slide, but interestingly, at the bottom, we also have, in conjunction with this, a Select Similar histogram, which you can use. You can control the number of levels of the histogram, the specific property that you wish to analyze your entities, your geometry with, and then that histogram is delivered to the messages window in the Pointwise interface, and then you can use that information also for selection. And so instead of having objects that are almost nearly identical, you can have a range of objects that are similar and select them by those properties. Additionally, we're adding the ability to select entities based on their hierarchy. And this isn't just for geometry, as you can see in the first image in the middle. We also have the hierarchy of grid entities or mesh entities in Pointwise, from connectors, which are your 1D elements, up through blocks, which are your 3D elements in Pointwise. And then on the right is your CAD geometry, so you can use the hierarchy starting at the basic surface or curve all the way up through model entities. And then we've also added the hierarchy that's kind of native to Pointwise, which is the constraint hierarchy between grid and the geometry, or what we call database. And so we have a number of tools available now related to those hierarchies that you can also use for selection to quickly, for instance, find and select all the parents of a particular object and accelerate that selection process. One of my favorite new capabilities that we've also added to enhance the selection process is a very simple one, it seems like, but I think it's going to be a favorite, and that's just simply the ability to filter the list of objects that you have for selection in what we call our list panel. So all the entity types, grid entities, geometry, sources, if you're using those, have names associated with them, and you can use this new filter to essentially whittle down that list, to declutter it essentially, and really accelerate selection based on naming. And this plays really well with some of our recent new additions to Pointwise, automatic surface mesh and volume mesh that I mentioned a few minutes ago, because those tools will take naming from your geometry, carry it through the entire meshing process, and you can access that quickly with this filtering tool for selection, for instance, to set boundary conditions for export to SU2 or other flow solvers. And then finally, for selection, I just want to talk briefly about some additional changes that we've made to masking. The mask tool in Fidelity Pointwise allows you to control what object types can be selected at any given time. And it can be anything from all the types at once to specifically curve grid entities, which we call connectors. To make this process work a little bit more efficiently, we've added the ability to create custom masks, save them, put them on the toolbar in the GUI. And additionally, specifically related to working with geometry preparation, we've added some new mask objects that you can put on the toolbar specifically for quilts and for model entities, because we find that users are often working with those in their preparation of their geometry. And so that's a really nice addition. And so that finally brings me to some of the bigger features that have just come out. And this is version 2023.1 that I'm referring to. It came out about a month ago. And the first one here is actually a tool that you can use to modify the geometry, what we call quilts, which are essentially surfaces or trim surfaces in Pointwise. You often can find that you need to essentially split quilts, especially regular surfaces. And then the images in the right, I've got some fillets shown, filleted surfaces. Often you want your topology to be split along those fillets. And while we had the tools in Pointwise previously to be able to do this, it was a multi-step process, and this new trim geometrically tool accelerates that process very quickly for you by essentially finding, for instance, the bisect tool, the top left image, finding those center lines for you parametrically within the surface and allowing you to quickly split those without really having to do much else. And a nice addition along with that is the ability to have it select automatically adjacent or all adjacent surfaces that may propagate through the geometry and bisect them all very quickly. And so this tool gives you the ability to do that. And there are other applications. One that I've already been using it a lot are control surfaces, the leading edge of a blade, or some type of a wing or stabilizer. When you need to have that geometric feature line for your meshing, you can easily do it now with this tool. And so that'll bring me to the marquee feature in this set of tools that we've added to try to automate and accelerate geometry preparation, and that's what we call assisted quilt assembly. This tool is included as part of what we refer to generally as flashpoint tools in Fidelity Pointwise, which includes automatic surface mesh and volume mesh that I mentioned briefly earlier. This command is going to use actually some of the capability that we developed for automatic surface mesh to go through your geometry and classify the quilting or the surfaces that is in it and group them together in an automated fashion based on those features, whether they're hard corners or features that are defined by soft curves, such as leading edges, as I mentioned a minute ago, or even these fillets. And one of the things that we've done in developing these side by side with trim geometrically is any of those quilts that you use trim geometrically for, we assume in the code that you trim those intentionally as features for your mesh, and so those become hard features in this tool for the quilting process. And so assisted quilt assembly is going to help you form those groups of quilts automatically based on these geometric features. And when you exit from the command, it will go ahead and automatically assemble all of those groups for you into single quilts, which will become useful in automatic surface mesh to become essentially surface grids in the meshing process. The tool also gives you the ability to provide names for those groups, and those names are applied to the new quilts that are generated when you exit the command. Excuse me. And then finally, in addition to all these other capabilities, we always are working on I/O and Fidelity Pointwise with every release and adding new capabilities. One of our popular capabilities for the field or the volume grid outside of anisotropic regions or boundary layer regions in the mesh is this voxel initialization capability that we have. And one of the things that we've had requested from users is to improve the zipper regions between these different levels of hexes in these voxel initializations, so that we don't have those what we call zippers of essentially pyramids and tetrahedra. And so we've added a new export capability in this latest version that will convert those zipper regions into polyhedra at export. And of course, it essentially eliminates the majority of those tetrahedron and pyramids that are in the mesh, at least in the voxel region of the grid. And so I think I'm getting close to the end of my time. I would just like to give a big thank you for this opportunity to review some of these developments that we have in Fidelity Pointwise that have, again, just come out about a month ago. in version 2023.1. Again, I'd just like to reiterate that all of this capability, as all the other capability in Pointwise, is scriptable with our built-in glyph scripting language. And again, thank you for this opportunity to tell you about our developments. And so I'll take any questions anybody may have.
Thank you, Eric. Is there any question in the audience? Either?
Yes. I was wondering, so at the beginning you showed that fixing things like a lot of time. Did you things like run tests where you compare manual tweaking to the newly improved features that you implemented?
Yeah, so Eric, so
Yes.
the question is about the comparison between, let's say, a manual adjustment of the geometry with respect to what you mentioned regarding the automated capabilities of Pointwise to do so.
Yeah, that's a good question. I think it's actually mentioned here on the slide. For this initial work that we've done, we have found that in the bottom bullet there that there's a good 2 to 3 times speed up than basically the manual work that you've needed to do in Fidelity Pointwise previous to this. For certain geometries that we've tested on, these automated classifications of various boundaries for the quilts works extremely well, and we've had some aircraft geometries and some other typical geometries that our users are working on that have essentially quilted nearly 100% with just maybe 1 or 2 adjustments in this command. So basically bringing that geometry into this command, it's already grouped the geometry into logical quilts based on these classifications at nearly 100%. And so with just 1 or 2 modifications, you can exit from the command and it's quilted and ready to go into automatic surface mesh. For other geometries, they may require a little bit more manual intervention, but it still can save a tremendous amount of time by, automating that grouping process.
All right. Thank you, Eric.
Yep.
So,
thank you.
Is there any?
Maybe one more.
One quick question, yeah?
Okay, so we use Cadence for our machinery applications, but we wanted, we normally import the CDNs into generation tag boundaries and then export the SU2 file to use in SU2. So I was wondering if I can import the Cadence rotary mesh into Pointwise and use the scripting tool in Pointwise to tag the boundaries so that I can put all that in my design optimization.
Yeah, so the question, well, let me reformulate it. So the question is about the seamless integration between Pointwise and SU2. If you can elaborate on that. So maybe.
So you mean in terms of just exporting the mesh to SU2?
Exactly.
Yeah.
I can email you my question.
Yeah.
Yeah, it's just for the total machinery applications that design optimization team we use Oracle, which is Cadence.
Yeah, so it's a different package than Pointwise. So you're talking about taking a grid from one of their packages, moving it into Pointwise, exporting. Okay. Maybe we can write that out, because I think it's a very specific question, Eric, for you about whether we can sort of chain between a couple different Cadence packages to get the boundary condition, or to get the surfaces in the mesh tagged correctly with names.
Okay, it does. Yeah, I can certainly follow up on that question offline. My email address is here. It's very simple. So yeah, just send me an email and and we can follow up on that.
Yeah, thanks, that'll be great.
Great. So just one last comment from me. Eric, thanks for coming again. So we really appreciate, all of your guys' support at Cadence Pointwise. Let's just call it Pointwise for now. We're glad to have you here. We hope to have you back next year. So thanks for coming.
Thank you. Thank you again for the opportunity.